Hello everyone. For this lecture, we will see about armature reaction in the alternator. Now, this armature reaction, we will see about definition first. The effect of armature, is the stator flux on the flux produced by the rotor field pole is called as armature reaction. म्हणजे काय जो काही स्टेटर करंट मुळे जो काही फ्लक्स तयार होणार आहे, the effect of the stator flux on the main flux. Okay, the effect of armature flux on the main flux which is produced by the rotor field poles is called as armature reactions, or simply in simple called as the effect of the armature current flux on the main field pole flux is called as armature reaction. When the current flows through the armature winding of an alternator, a flux is produced by a resulting mmf. Okay, when the current always flows through the armature winding of alternator, obviously flux is produced. This armature flux reacts with the main pole flux, causing the resultant flux to become either less than or more than the original main field flux. म्हणजे सिंपल काय तर जेव्हा आर्मेचर अल्टरनेटर फिरायला लागेल आर्मेचर मध्ये ऑब्व्हियसली काय होईल, फील्ड कट केला आर्मेचर मध्ये करंट फ्लो होणार आहे. जो आर्मेचर मधला करंट मग जो काही फ्लक्स तयार होणार आहे तो फ्लक्स काय करतोय तर मेन फील्डला, म्हणजे ज्याच्यामुळे जन्म झालाय कुणामुळे जन्म, आर्मेचर करंटचा जन्म कुणामुळे झाला तर मेन फील्ड मुळे त्याचा जन्म झाला. तर द करंट इन द आर्मेचर इट it reacts with the main field flux. म्हणजे मेन पोल बरोबर आर्मेचर करंटचा जो काही फ्लक्स तयार होणार आहे, आर्मेचर करंट फ्लक्सेस इट विल reacts with the main pole flux, and this will cause either resultant flux to become either less than or more than the original main field flux, which is called as the armature reactions. Okay, so for simplicity we consider a three-phase two-pole angle between the armature phase current and the induced alternator shown in the figure below. That means this one. Okay, so this is nothing but an armature, this is nothing but an alternator. So in that part this is nothing but a field pole which is created by the rotor. Okay, ha rotor आहे तुमचा मधला, this is part of stator. Now armature reactions means what? The armature reaction in a synchronous motion affects main field flux and vary differently for different power factors. That means what? सिंपली नाव आता काय होणार बघा, हा आर्मेचर तुमचा रोटर फिरणार मग काय झालं, हा फील्ड आपण फील्ड वाने कनेक्ट केलं नाही तर मग फील्ड वाने कनेक्ट केलं, मग रोटर फिरायला लागला, मग काय होतं इथं आर्मेचर मध्ये आता EMF तयार होणार बाय अकॉर्डिंग टू फॅरेडेज लॉ. ओके, सो वन्स EMF is created in the stator, now current is going to flow in the stator. Now this, because of this current, now what will happen, the stator flux is created here. Okay, in this part stator flux is created. Now this stator flux will react with the this flux we call rotor flux or called as the main flux. This stator flux will react with the rotor flux, and this reaction we called as the armature reactions. Now the armature reactions ka तर armature flux it will react with the main flux, we simple call rotor flux. Okay, this is called armature reactions. Now here armature reactions is discussed for following three conditions, namely as for unity power factor, second zero power factor lagging or simple called as zero power factor or lagging power factor, and third one zero power factor leading, we simple called leading power factor, simple called power factor which have a leading natures. The power factor can be defined as the cosine of the EMF in the armature conductor in that phase. Okay, now we will move to the first part we called the armature reaction at unity power factors. Okay, at unity power factors, as we know that the direction of rotation of the rotor is considered clockwise. By applying right hand rule, the direction of induced EMF various conductors can be found. Simply what? Now this is nothing but, as we know that for unity power factor, the current it is always in phase with the voltage. Okay, for unity power factor, as we know that the current in all phases it is always in phase with the voltage level. That means I called IA, that is armature current in A phase, which is always it is in phase with the EA, that is voltage in A phase. Similarly IB, EB and IC, EC. Okay, now suppose that the alternator is supplying current at unity power factor, the phase current IA, IB and IC will be in a phase with the respective generated voltage, that is EA, EB and EC, as shown in figure A. Okay, now the positive direction of the fluxes phi A, phi B and phi C are shown in the फिगर बी. दॅट मीन्स व्हॉट, हे फाय ए फाय बी फाय सी कुणीकडनं आलं, कसं आलं, तर फॉर दॅट वी सिम्प्लिसिटी वी अज्युम दॅट नाव माय डायरेक्शन ऑफ रोटेशन ऑफ रोटर इट इज इन क्लॉकवाइज डायरेक्शन. दिस I have shown the phi AR. Phi AR म्हणजे काय? This is the resultant armature flux. Flux, phi means flux. A means armature, R means resultant. Okay, this is nothing but a resultant armature flux. Now this is the direction of the fluxes. We call positive direction of the fluxes. Now for we are considering at t instant, at t equals to 0 instant, the instantaneous values of currents and fluxes are given by the equation shown below. Okay, for any instant we call t instant, instantaneous value of current, we are taking the values of current. Okay, so Ia is equals to Im and phi a equals to phi m. Ia equals to Im कुणीकडनं आलं, because at this, okay, phi AR direction इकडे अशी आडवी आहे. Okay, so Ia, that means it is in phase, so phi AR direction, it is in these directions. So here my positive flux direction with the phi AR. Okay, so I can show that Ia is equals to Im and phi equals to my phi m. Okay, so Ib is equals to minus Im cos, म्हणजे कुठं आलं, Ib equals to Im cos omega t. Just simply, as we know that I equals to Im cos omega t. This Im means maximum current, Im cos omega t, and cos omega t, this omega t is nothing but 60 degree. That is, we can't find, by solving this we can get equals to minus 1 by 2 Im and phi b equals to minus 1 by 2 phi m. Okay, similarly Ic equals to minus Im cos omega t, that is minus Im cos 60, that is equals to minus 1 by 2 Im, and phi c equals to minus 1 by 2 phi m, where the subscript m denotes the maximum values of current and flux. Thus, the flux phi A is along OA and the flux phi B and phi C are negative and acts opposite to each other, represented by OB and OC respectively, as shown in the figure below. Simply काय, इथं as per this direction, you can look these directions, phi A, phi B and phi C. This is nothing but a direction of the positive fluxes. Okay, this is nothing but a direction of the fluxes. Now what, we are taking reference of this figure in the disk. Okay, phi AR. So here, as I said, phi B and phi C. मी phi C काय केलं, हा वरती डॉट 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 ढकलला वरती आणि phi B इकडे खाली ढकलला. ओके, phi B म्हणजे मायनस phi B खाली आला आणि हा वरती मायनस phi C गेला. रिझल्टंट मागे घेतला ना आपण, रिझल्टंट हा phi C इथं आहे, मागे एक्सटेंड केलं तर मायनस phi C होतो. हा phi B इकडे आहे, हा खाली घेतला तर मायनस phi B होणार आहे. ओके, हा मी असं अज्युम केलेलं आहे. नाव this is direction of main rotor flux. Now I can get the phi AR equals to 1.5 phi am. Okay, हे कसं आलं? Which is nothing but a calculations. Resolving along the horizontal direction we get, that means according to that, this is direction of main rotor flux. Now phi C equals to 0.5 phi m and phi B equals to 0.5 phi m. हे कुणीकडनं आलं? Because as this shown here, my rotation of my rotor main field flux is from this, म्हणजे हा असा डायरेक्शन माझा, आता माझं रोटर इथं स्टँडस्टिल अज्युम करा, टी इन्स्टन्सला टी इक्वल्स टू 0 इन्स्टंटला माझं रोटर पोझिशन माझं असं आहे, म्हणजे काय, मॅक्सिमम फ्लक्स ए कंडक्टरला पास व्हायला नाही, इथं एन असतं, म्हणजे ए टू इथं फ्लक्सला कट मॅक्सिमम इथं व्हायला लागले, कटिंग व्हायला लागले. So I can get, by solving this I should have the take the resultant fluxes of this resolution of two fluxes. So phi h, which is h indicates the horizontal direction resolution, phi a minus phi b cos 60 degree minus phi c cos 60 degree. By solving this I can get minus phi equals to minus 1.5 into phi m. Similarly, resolving along the vertical direction we get phi b, this for vertical direction, y equals to minus phi b cos 30 degree plus phi c cos 30 degree. That is, by solving this, phi b equals to minus 1 by 2 phi m cos 30 plus 1 by 2 phi m cos 30 equals to 0. That means both are cancels each other. So I can get resultant armature reaction flux is given by phi AR is equals to this one. It's horizontal square root of horizontal flux square plus vertical flux square, that is called 1.5 phi m square. That is I call phi AR equals to 1.5 phi m. Just simply what, for the armature reaction, if the power factor is unity, then I got the armature, that is phi AR, that is resultant armature flux is equals to 1.5 into maximum fluxes. Hence it is observed that The resultant flux phi AR sets up by the current in the armature remains constant in magnitude equal to 1.55 and it rotates at synchronous speed. When the current is in phase with the induced voltage, the armature reaction flux phi AR lags behind the main field flux 90 degree, and this is called as a cross magnetism flux. That means what? If my power factor is unity, then the effect of armature reaction is having the cross magnetization. Okay, cross magnetization little bit it called the distortion. Okay, this is unity power factor. Now we will move to the second one. This is armature reaction at lagging power factor. Okay, now if the alternator is loaded with an inductive load of 0 power factor lagging, the phase current IA, IB and IC will be lagging with their respective phase voltage EA, EB and EC by 90 degrees. As we know that if the power factor is lagging, then always the currents is always lagging by 90 degree. That means is EA, it is 90 degree displacement. Now EB, IB here is 90 degree displacement and EC, IC here is 90 degree displacement. All these current are lagging with respect to the voltage. Okay, the figure shows the phasor diagram of armature reaction at lagging load. Now, similarly, at time t equals to 0 instant, the instantaneous values of current and fluxes are given by Ia is equals to 0 and hence phi is equals to 0. Because here what will happen? Now I can assume that my phi AR, the direction of here, the direction of main resultant, it is this direction, the negative direction line, left direction line. Now for this lagging power factor nature, I got the current direction, it is exactly opposite to that one. So I'm taking this Ia equals to 0 and hence if I equals to 0, obviously my phi is equals to 0 and IB equals to Im sine of omega, that is a sine minus 120 degree. हे कुठून आलं? By using these directions. Okay, now EB, this having, it is, suppose I'm taking this EB, it is having a minus 110 degree displacement, and similarly IC, Im equals sine plus 120 displacement. म्हणजे मेन फील्ड फ्लक्स डायरेक्शन अशी आहे आणि माझा EC इथे आहे. You can take here EB equals to minus 120 and EC equals to minus 240, म्हणजे इथून 240 degree minus, or simply you can take at 120 degree plus. Okay, म्हणजे कसं आलंय, according to this direction my resultant my main field flux is here, म्हणजे अशी डायरेक्शन आहे माझी. ओके, नाव IA current obviously माझा IA 0 current असणार because main field flux च्या exactly opposite, so I take this is 0 1. Now this one, okay, IB, this IB, so it is having nature of this IB is having minus 120 degree. Okay, minus 120 degree and IC equals to minus 240 degree, or simply it is having a leading with the main current as 120 degree. The space diagram is simple called a phasor diagram of magnetic fluxes as shown below. So this one phi c equals to root 3 by 2 phi m, phi equals to my root 3 2 by phi m, and suppose I'm taking the resultant of these two vectors, I got phi AR, that is resultant phi is AR equals to 1.5 into phi m. Okay, the resultant flux phi AR is given by the equation shown below. This is this simply called as this. I'm taking the parallelogram of parallel. This is nothing but a parallelogram. So I'm taking resultant of these two vectors. I got phi AR square equals to phi R square plus phi C square, and by solving this I will get phi AR equals to 1.5 phi m. The direction of armature reaction flux, it opposite to the main field flux, therefore it will oppose and weakens the main field flux and is said to be demagnetizing. म्हणजे माझा टोटल रिझल्टंट मी ह्या बाय युजिंग दिस इक्वेशन मी रिझल्टंट फाइंड केलाय. बाय रिझल्टंट माझा इथं खाली आलाय, म्हणजे काय माझा ऍक्च्युअली रिझल्टंट मेन फील्ड फ्लक्स डायरेक्शन कुठे आहे, तर मेन फील्ड फ्लक्स डायरेक्शन वरती आहे. ओके, दिस इज नथिंग बट डायरेक्शन ऑफ द मेन रोटर फ्लक्सेस. ओके, नाव माझा फाय आर इथं आला, माझा मेन इथं फॉर युनिट पॉवर फॅक्टर माझी डायरेक्शन इथे अशी उभी आहे, वर्टिकल डायरेक्शनला माझे मेन फील्ड आहे. बट माझा ऍट युनिट पॉवर फॅक्टर काय झाला, इथं आहे म्हणजे आडवा आला, हॉरिझॉन्टल आलाय. सो काय होणार इथं माझा मेन फील्ड फ्लक्सला क्रॉस मॅग्नेटायझिंग इफेक्ट म्हणजे थोडंसं डिक्रीज होणार, म्हणजे डिस्टॉर्शन होणार आहे. नाव सिमिलरली and this figure, now at lagging power factor what will happen, my resultant flux it is I got in the downward direction, but in actually I should have in म्हणजे actually माझं main field flux direction vertical आहे, but by solving for lagging power factor I got the nature which is of the downward direction, and hence I can say that the direction of the reaction flux is opposite to the main field flux. मेन फील्ड फ्लक्स ची डायरेक्शन कशी आहे, तर मेन फील्ड फ्लक्स ची डायरेक्शन इथे आहे, वर्टिकल आहे. बट फॉर दिस आय गॉट here opposite to the main field flux, and hence therefore it will oppose and taken main field flux and said to be demagnetizing. Now for third, we will see about armature reaction at leading power factor. Okay, as we know, the leading power factor, the current is always in leading position with respect to the voltage. If the alternator is loaded with a load of zero power factor loading, the phase current IA, IB and IC will be leading the respective phase voltage EA, EB and EC by 90 degree. The phase diagram is shown. That means for leading power factor, as you know that always this current, that is a current IA for this current is always leading by 90 degree with respect to their voltages. So as shown in the figure, IA is lagging, IA is leading with EA by 90 degree. IB is leading with the EB with 90 degree, and IC it is leading with IEC with the 90 degree. Now for this, again we are showing for at the time t equals to 0 instant, the instantaneous value of current and fluxes are given by the equation shown below. I equals to 0 and again hence phi is equals to 0. So IB equals to Im cos 30 degree. That is, by using this we can calculate cos 30, that is root 3 by 2 Im, and phi b equals to root 3 by, that is hence phi m equals to phi b equals to root 3 by 2 phi m. And similarly IC equals to minus Im cos 30 degree, and hence it is having minus value minus root 3 by 2 Im, and phi c equals to hence minus root 3 by 2 phi m. The direction of the flux is shown below in the phasor diagram. So this one now this I will got by using this phi b and phi c. Phi b I got about root 3 by 2 phi m. So this phi b I shown by this vector. Similarly for phi c minus root 3 by 2 phi m. So these two, and suppose I'm taking resultant of these two phi b and phi c, I got about phi a. That is the resultant of fluxes, we call it resultant armature fluxes. So I got about phi b, which is having this angle, and phi c is having this angle. So okay, so suppose I'm taking resultant of these two, I got about phi a, which is having again upward direction. Okay, now because of this resultant, it is a upward direction. The resultant flux is given by the equation shown below. Phi r square equals to phi b square plus phi c square and into plus 2 phi b phi c cos 60 degree. By solving this, we'll get phi r equals to 1.5 into phi m. The direction of the armature reaction flux is in the direction of the main field flux, and hence it is known as a magnetic flux. As we know that the direction of main field flux is in upward direction, here vertical direction. Now by resolving these two fluxes, I got the direction of this fluxes for leading power factor. It is again in upward directions, and hence nowadays the direction of the armature reaction flux is in the direction of main field flux, and hence it is known as the magnetizing fluxes. So as if we have the leading power factor load, the armature reaction is always having a magnetizing fluxes, or we call it magnetizing reactions. Now this is a summary of armature reaction. The armature reaction is cross magnetizing when the generator supplies a load at unity power factor. Okay, cross magnetizing as we saw. So due to the cross magnetizing effect, voltage get reduced. That is the terminal voltage or generator voltage get reduced. Similarly, second one, when the generator supplies a load at lagging power factor, the armature reaction is partly demagnetizing and partly cross magnetizing. And due to demagnetizing effect, the voltage get reduced. Again, now we can see that in the if armature reaction is a cross magnetizing effect, this cross magnetizing effect is always possible in it always appear at the unity power factor load. Okay, and if the cross magnetizing effect, due to cross magnetizing effect, what will happen? My terminal voltage get reduced. Similarly for demagnetizing effect, what will happen? My demagnetizing effect is appear at a lagging power factor and always lagging power factor nature. So this, because of this demagnetizing effect, again my terminal voltage get reduced. And third one, when the generator supplies a load at leading power factor, the armature reaction is a magnetizing effect. Okay, as we see. So due to the magnetizing effect, the voltage get increased. Okay, in both cases my voltage get reduced at unity power factor and as well as in lagging power factor. But in leading power factor, armature reaction is magnetizing, and hence my terminal voltage get increased. Now we'll see about the synchronous impedance of alternator. Now as we know that the terminal voltage, by using this previous discussion, we will see that the terminal voltage of alternator can be given as V, total V is equals to EA, that is a induced EMF of armature alternator. EA is equals to, yeah, it's a V equals to EA minus IARA minus JXAI minus JXARI. सिंपल काय, माझं टर्मिनल व्होल्टेज मला किती मिळणार आहे बाहेर, टर्मिनल व्होल्टेज म्हणजे द व्होल्टेज विच इज अवेलेबल बाय द टर्मिनल, V इक्वल्स टू EA, दॅट इज इंड्युस्ड EMF ऑफ अल्टरनेटर मायनस IARA म्हणजे काय, IARA दिस इज अवेअर, IARA इक्वल्स टू आर्मेचर रेजिस्टन्स ड्रॉप. ओके, म्हणजे सपोज जरी मध्ये इथे सपोज इथे 100 व्होल्ट, सपोज फॉर एक्झाम्पल टर्मिनल व्होल्टेज मी काय म्हटलं इथे सपोज 100 व्होल्ट मध्ये जनरेट होत असेल, सो EA induced 100 volt. Suppose I assume, okay. So again minus IR म्हणजे सपोज IRA परत सपोज इथे 5 व्होल्ट ड्रॉप होते, मायनस JXAI म्हणजे काय, XAI म्हणजे काय, आर्मेचर लिकेज रिएक्टन्स. सपोज इथं परत 5 व्होल्ट ड्रॉप होणार, आणि अगेन XAR इंटू आय तर आर्मेचर रिएक्शन व्होल्टेज म्हणजे 5 व्होल्ट, म्हणजे मला किती मिळणार 100 मायनस 5 मायनस 5 मायनस 5, म्हणजेच टोटली मला I got only 85 volt as a terminal voltage, even though in the generator 100 volt is induced. Induced EMF is having, it is always more than terminal voltage. Okay, so induced EMF is EA minus IARA minus JXAI minus JXARI. Okay, the armature reaction effect and the leakage flux effect in the machine are both represented by inductive reactances, because as we know that this X factor is nothing but a fictitious or simple called as a, it's imaginary factors. Okay, so it is possible because of the both having inductive reactance. Therefore it is customary to combine them into single reactance, and it is called as a synchronous reactance of the machine axis. मी simple काय केले, मी काय केले इथला, okay, this drop is because of the ohmic drop, this is because of the I square R, that is I square R, yeah, I into RA. Okay, now this drop is because of the inductive drop. Okay, so I'm combining XS, it equals to XA, that is leakage reactance, plus armature reactance, this one XAR. Okay, so I saw XA, I replace XA plus XER, so I got again I rewriting this equation, V equals to EA minus JXSIA XS म्हणजे काय, a synchronous impedance, synchronous reactance. Okay, synchronous reactance into current minus IARA drop. So V equals to EA minus, just I'm taking IA common, so RA plus JXS. Okay, so V is equals to EA minus ZS. So this RA plus ZXS I represent as a ZS. Okay, that is a RA plus X म्हणजे simply called as the impedance. Okay, and this ZA I can define as RA plus XS JXS, and this impedance ZS is called as a synchronous impedance. Always you should remember this is nothing but a voltage equation of alternators. Okay, the whole terminal voltage of alternator always reduce the induced EMF because of ohmic drop, because of this drop in the leakage reactance, and because the drop in the armature reactions. Okay, म्हणजे ड्रॉप टर्मिनल व्होल्टेज मला अल्टरनेटर्स ऑलवेज कमी का मिळणार आहे, तर एकतरी माझं इथं हो म्हणजे रेजिस्टन्स ड्रॉप होणार आहे, प्लस लिकेज रिएक्टन्स ड्रॉप होणार आहे, as well as it is dropped because of the armature reactions. Okay, so I'll got the V equals to EA minus ZS into I, this ZS equals to RA plus JXS, and the impedance ZS is called as a synchronous impedance.